All right, here we go. So, yesterday I guess we've been doing this for a minute. We are talking about finding our discontinuities, right? And so we went through the steps of finding our discontinuities. Step 1, we factor the numerator and denominator. Step 2, we look for values that are zeros of both numerator and denominator. That tells us our wholes. Step 3, we look for values that are zeros of the denominator, and that tells us our vertical asymptote. And step 4, compare the degrees of the numerator. All right, guys, at this time, you don't need your computer. If your computer is open, that tells me you're not paying me any attention. Okay, you should have your notes out. And there, that's it. Okay. All right, so, and then step 4 is comparing the degrees of the numerator and denominator, and that's going to tell us our horizontal asymptote. So, at the end of class yesterday, we left off with the I do, which is the one I worked through. So following those steps, the first thing I did was fully factor using my factoring techniques. Second, we look for what factor did they have in common, and that was x minus 2. When I set that equal to 0, that tells me where my whole is, okay? Step 3 is to look at what's left in your denominator. What variables are left in your denominator? And I'm left with x plus 2. I set that equal to 0, and that tells me my vertical asymptote, okay? It's an asymptote because your denominator cannot equal 0, right? Step 4 is then to compare the degree of your numerator to the degree of your denominator. And our degrees were the same. When your degrees are the same, that means you have a horizontal asymptote at y equals your leading coefficients, okay? Your leading coefficients are the numbers that are with the highest exponent. Your highest power of your variable. That's your degree. That's why it's degree 2 and degree 2 here. Okay. And then that's what we did. So we're going to do number 1 together, walk through the steps, and then I'm going to pause and give you about 6 minutes to do 2 and 3. Okay. At your tables. So we're going to do 1 together, and then we're going to pause, and you're going to do 2 and 3 at your table for about 6 minutes. Here we go. So number 1. First thing you want to do is to fully factor. Is this fully factored? No. This is difference of 2 squares. So to fully factor this, it becomes x over x minus 3 times x plus 3. Now is it fully factored?
How do you so fast? Yeah. We know that 9 is perfect square and x squared is perfect square.
And they're being subtracted. I mean, if you have 2 perfect squares being subtracted, then they factor out to being the square root of the first term plus or minus the square root of the second term.
No, I know, but like,
anytime you see 2 perfect squares being subtracted, you should think difference of 2 squares. Yep. All right, step 2 is to identify any common factors. Do they have anything in common? No, so that means there are no holes. It literally looks like a space in the graph. It's really hard to see on larger graphs, but when you're drawing it, you put a space. I put a hole generally.
like if you're doing a straight line, it's not.
On the table, just say error at that. All right, on 3, we're now going to look at what factors are in our denominator and set them equal to 0. Do we still have factors in our denominator? Yes. So we're going to set each factor equal to 0. So when I set each factor to 0, the value that I get for x, those are my vertical asymptotes. So where do I have vertical asymptotes at?
3 and negative 3.
3 and negative 3. X equals 3, x equals negative 3. Okay. Step 4 is going back to the original and comparing the degrees of your functions. I mean, of your numerator and denominator. What is the degree of my numerator? 1. It's Casper the Friendly 1. If there's no power, then the power is 1. What's the degree of my denominator? 2. So we said when the degree of your numerator is less than the degree of your denominator, what does that mean?
It's a whole x equal a.
At y equals 0. If there's a horizontal asymptote at what? Yes, as we wrote in our notes yesterday. I don't know. I use a different set of notes this year, and they use M and N. I usually use N and D. You can switch it if it bothers you. They're your notes. At y equals 0. So these are our discontinuities. Vertical asymptotes and a horizontal asymptote.
And there be two vertical.
Yes, you can have 2 vertical asymptote, but only 1 horizontal. Or no horizontal, or no vertical.
So if the, wait, but isn't the denominator in this one bigger than the numerator, the 2?
Yeah.
Oh, it's in a denominator.
Mhm.
In its denominator? I thought in was numerator.
So yesterday in our notes, we defined it. The degree of the numerator is going to be m. The degree of the denominator is n. If m is less than n, it's a horizontal asymptote. If m is greater than n, you have no horizontal asymptote. And if m equals n, you have a horizontal asymptote at your coefficients. Okay. All right. So I'm gonna put 6 minutes on, and you're gonna do 2 and 3. So we will check back at 9:48. All right, so on number 2, the first thing is you should have factored it. When you factored, rule number 1 of factoring is always check for a GCF, right? Greatest common factor. Is there a greatest common factor?
Yes.
Yes, you should have factored out the 6 first. Okay, after you factor out the 6, you're left with difference of 2 squares. So you have 6 times x minus 1 times x plus 1 all over x minus 1. Okay, step 2 is to ask yourself, are there any common factors? And the answer is yes. What is my common factor? X minus 1. So I'm going to set that equal to 0, and I get x equals 1, and that's where my hole is. So I have a hole at x equals 1. Step 3 is your vertical asymptote. When I remove this, is there anything left in my denominator? No. So then therefore there is no vertical asymptote. Okay. Step 4 is going back to the original problem and comparing the degrees. So the degree of the numerator is 2. The degree of the denominator is 1. So since the numerator is greater than the denominator, that means that there is no horizontal asymptote. The numerator is greater than the denominator? We discussed that already. I followed someone else's note.
The m's of the denominator.
Mm-mm.
I know.
Alphabetical order. Yeah.
Numerator.
Guys. All right, here we go. So the only discontinuity here was a hole. Okay. On 3, it is already fully factored. There's no GCF. There's no difference of 2 squares. There's no simple trinomial. It is fully factored. Step 2, do they have anything in common? No, no holes. Step 3 is your denominator. And is there something in my denominator? Yes. So I'm taking 3x minus 2, but plus 2 and setting it equal to 0. So 3x plus 2 equals 0. I end up with 3x equals -2. So x equals -2/3 is a vertical asymptote. Okay. Step 4 is your horizontal asymptote. Comparing the degrees. Our degrees are going to be the what? 1 and 1, they're the same. So m equals n. So y equals your leading coefficients. What are my leading coefficients? 4 and 3. So y equals 4 over 3 is our horizontal asymptote. Yes. Okay? And that is what you should have gotten for 3.